In this video, I'll demonstrate how to calculate susceptibility and inverse susceptibility, fit a line to a graph to determine Curie Weiss temperature, as well as how to create a 3D plot for the SFD, switching field distribution, the MDH distribution, and obtain the calculated data using MagnetoCaloric software without using any third-party software. I'm currently using version 0.3.9 of this software, which is built upon the mcepy Python module. If you'd like to access this software for your research, please visit the documentation page and contact the developer via email to request access. The MH data I've used is programmatically generated, which is why the hysteresis curve might not appear as expected, but we can overlook this for the purpose of the demonstration. Let's start by creating plots for susceptibility and inverse susceptibility to gain a better understanding of the sample data. If you only want to visualize susceptibility and inverse susceptibility, you can keep the threshold value at 0. However, if you wish to perform a linear fit for the points above the Curie temperature, adjust the threshold values accordingly to find the Curie Weiss temperature experimentally. Now, as we can clearly see, the intercepting point reveals the Curie Weiss temperature. The software will automatically save this value in the output folder, allowing us to easily verify it. To create a plot for the switching field distribution, SFD, an important parameter in magnetic media, representing the dispersion of fields needed to reverse the magnetization direction of individual grains, simply follow these steps. Here, we can observe the DMDH distribution from both temperature and applied field perspectives, and obtain the results for future use.